In previous lessons, we talked about congruent triangles and we use side, side, side and side, and angle, and all these things to prove that these triangles were congruent. Well, now we're going to take a couple of those, only two actually, side, 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 and side, side, and then we're going to add in angle, angle to prove that these triangles are just similar. So remember, similar just means that they have congruent angles, but that their sides are now proportional instead of congruent. And then we're going to solve a couple of problems. So I'm going to kind of fly through these definitions because these are things you already know and have used before. So the first one, angle, angle similarity. Now this one is kind of new, but basically if you have two triangles and you have two angles that are congruent in each, so A and H and then D and G, if those are congruent, then that automatically makes the triangle similar. And if the triangles are similar, that means your sides are proportional, okay? The next thing that we have is side, side, side. And so again, instead of the sides being congruent, if they are all proportional, so this part right here, if you were to write out a, more like a extended proportion and set them all equal and get the same number each time, then those two triangles will be similar. Then we have side, angle, side. So two side lengths that correspond need to be proportional, so they need to have the same fraction or same decimal, and then their included angle needs to be congruent as well. And remember, the included angle is the angle in between the two sides we're talking about. So in this case, we're talking about XC with BN down here, and then CV with MN over here. All right, so now I'm going to get into a couple of examples and talk about, how are they similar, how do we know, and what's their similarity statement. So for this first example, and you can actually find this on Edmodo, I put a printed version, or I'm sorry, a hard copy of this, so you can print it out. You don't have to redraw all of these. So I would recommend printing that out ahead of time. But anyway, so in this first example, are they similar? Well, let's look at these two triangles. They're same shape, they're different sizes. So could they be? Yeah, possibly. Now, when you notice that angle A and angle D are the same, and then angle B is congruent to angle E, that is our angle-angle similarity. So that's what we're going to put as our explanation, is that they are congruent, or I'm sorry, similar because of the angle-angle similarity postulate. So the similarity statement, so we would say yes then, because of angle, angle. And the similarity statement, we would write triangle, and if we call it ABC, is similar to triangle. Now since I started with A, I have to start with D. I went to B, and since B and E are congruent, E has to come next, and then F. All right, now our next example. So we have two right triangles. So are they similar? Possibly. We don't know anything about the angles, but maybe it's side, angle, side, because we have one angle and we have two sides. So let's match up our sides and see if they work. Because based on this, we don't know what sides match up. So I'm gonna have to kind of do a couple different matchups as much as we can. So if I take the 20 and I put that over, let's say, the 18 and say these go together, is that equal to 36 over 24? If you divide that out in your calculator, you'll actually see that they are not equal. 20 over 18 would give you 1.11 repeating, and then 36 over 24 gives you 1.5, and those are not equal. Okay, so that's one possible scenario. It didn't work. So what if instead I match 20 with 24? And is that equal to 36 over 18? Well, this 36 over 18 is 2. So we already know, based on that right there, 20 over 24 is not 2. It's not even 1. It's 0.83 repeating. And so those are not equal. And so then what does that mean? That they're not similar. They can't be, because their sides are not proportional. So there's no similarity statement to write because they're not similar, and your explanation would be that the sides are not proportional. There we go. All right, now example 3. We've got parallel lines, so remember those things mean that we have, whoa, that's entirely too many L's there. parallel, there we go, parallel lines. So that means we're going to have corresponding angles. So angle R corresponds to angle S, and then angle U corresponds to angle L. So we've got our angle-angle similarity again. So angle-angle similarity. So yes, they are similar. And then what would be your similarity statement? So if we name the first triangle RUT, we would say that that is similar to triangle. Now remember, we used R first, so we have to use S first here. Then we went to U, which is congruent to L, so we have to go to L, and then T. So this really is a triangle within a triangle. So really we've got this triangle here, RUT, and then we have a smaller version of that same triangle right here, SLT. All right, our fourth example and our final of this type of problem, just determining whether they're similar or not. So looking at this example here, and we would have to set up, are these proportional? It looks like it could potentially be side angle side, but is it really? So if we take 24 and put it over its corresponding side, or what we think is its corresponding side, and then we take 39 and put it over 26, you will see that they actually do come out to the same number. So 24 over 16 gives you a 1.5, and 39 over 26 also gives you 1.5. So because they came out to the same, we know that those are in fact the corresponding sides. So yes, they are similar. And this would be because of the side angle side similarity. And then you have to write your similarity statement. So starting with triangle, if I do FBE is similar to what triangle? Well, FB corresponded to LN, so I have to start there, and then M being the last letter. All right, a couple more examples, and in this one, not only are we going to do our similarity statement and explain how we know this, but then we're going to find a missing measure. So again, we've got parallel lines, which means this time we have got alternate interior angles. So those are congruent, and these here are congruent. We could do vertical angles as well, but we can stop there, all because of the angle-angle similarity. All right, so if those are similar by angle-angle, then let's write our similarity statement, and this will help us match up what sides are actually proportional. So if I do CAB, triangle CAB is similar to what triangle? Well, C is congruent to E, so E has to come first. A is congruent to D, so D comes second, and then B. All right, so when we're matching up our sides, 30 is in between angle C and angle A. So that corresponds to 60 because it's in between the same two types of angles. So I'm going to take the 30 and match it up with the 60. All right, now this X here. I'm going to use X on top because I use 30 and you have to keep it consistent. So since I was using the left triangle on top, I have to keep it that way. Now what does X go with? Does it go with 38.6? Where does it go? So if you're looking at it, it's between C and then B, which is vertical angles on both sides, and that does in fact go with the 38.6. So when you do your cross multiplying, when you multiply up and over, you get 1,158 equals 60x. You divide by 60 on both sides, and you end up getting 19.3 as your x value. And in this case, x is the length of BC, so it's just 19.3. There's no extra plugging in or any work to do from there. All right, number 6. So we've got parallel lines again, only this time, because of the way our picture is set up, we have corresponding, so same spot, different levels. So we've got congruent angles there and there. So this again would be angle-angle similarity, which you'll see pretty frequently in these types of pictures. A lot of the similarity, they like to use angle-angle a lot. So if I go with triangle QRF, that would be similar to triangle. Now I use Q first, so I have to use P, and then I have to go to N, and then F last. So what sides correspond? Well, if we're looking at this, what we really should do is pull these two triangles apart. Okay, so let's go ahead and do that and pull these apart. And I left you some room on that paper too. So FRQ, so FR is 30, FQ is 32, and then RQ we don't know. All right, and then our second triangle, which is a little bit longer. Man, that's hard to write down here. So FNP. All right, so F to N. So we've got 30 plus 10. So we have a total of 40 for that whole side there. This side is 22, and then F all the way to P. Well, we add our two sides, or our two pieces together to get the full length. So this is actually 32 plus X. So when we go to solve this, we need to match up our sides. So 30 FR, so FR is going to correspond to FN here. So 30 over 40 equals, and then 32 is what corresponds to our 32 plus X. So when we go ahead and do our cross products to multiply and solve, we get 960 plus 30x equals 1,280. Subtract 960 from both sides of your equation to get 30x equals 320. Divide by 30 on both sides of your equation to end up at x equals 10.67. And I'll go ahead and round it. Normally I don't really like you to, but that's all right. All right, so that's our x, which is just QP, and in this case, again, x is exactly what we're looking for. We don't have any plugging in to do. So 10.67. Now, if it asked for FP, we would have to add 32 to that to get the full length. All right, now our final example here is mainly just because you claim to hate word problems, and they're really not that bad. You just need to take out and learn how to take out the things that you need and ignore everything else. So we have two vertical posts, 2 meters, and then 0.45 meter. So I'm going to make a vertical post, vertical-ish, and then a smaller one that is 0.45. All right, the shorter post casts a shadow, so this is going to be the post here, and then this is going to be the shadow. Okay, so the shadow. And the shadow is 0.85 meters long. And now think about it. When a post is put in the ground, it's going to be straight up and down, right? It's going to make a right angle. And so I could potentially close this up. Now we have a right triangle here. Okay, now this post, we don't know how long its shadow is. Whoa, that was real bad. Let me try that again. Better. All right, so shadow would be down here. And it is what? X. We don't know. But what we do know is when people put posts in the ground, they put them in at 90-degree angles. So we could close it up from there. Okay. Now, the way that this is set up, we are able to write a proportion. So if we go ahead and do that, and now basically it has to be an assumption a little bit because they didn't tell you they were similar, but that they would have to be in order to find these, find this information. So you're going to take shadow over shadow, so x over 0.85, and set it equal to height over height, so 2 over 0.45. Do your cross products, 0.45x equals 1.7. Divide by 0.45 on both sides of your equation, and you end up with x equals 3.78, and you have to round it. I asked you to round to the nearest hundredth, and so that would be the length of the shadow to the nearest hundredth. So there you go. It's all about knowing how to write the proportions, keeping things consistent. I did larger triangle on top, smaller on bottom, and I did shadow here, and I did height here. So as long as you can keep it consistent, these are really not all that bad, pretty simple, and once you have the equation, you just solve it and you're done.